So hello everyone. Today we have our last session and it will be presented by Julia Wester. Perfect, yeah. And she will talk us about probabilities. What are the odds? Forecasting with probabilities. And now I would like Julia just to emphasize that she is co-founder of this organization, of this company. Yeah. And I would like to invite everyone think of questions, which I think Julia will provide on the spot. As we last talk, so we have be flexible. I think so. Yeah. And also think about the feedback after the presentation. The number for Menti is on our wall. Yep. And now, Julia, the stage is yours.
Thank you so much. And people, if you're coming in, don't worry about it. It's all good. Yes, please do remember feedback. That's helpful for every speaker to understand what worked well and what doesn't, especially if they're going to inflict their talk on another group of people. It's good to know what works and what doesn't. As Inga said, I'm Julia Wester, or Julia, that's also right. I live in southern Sweden. Obviously, I'm not from there originally, but this seems to be the Swedish block of the afternoon. We had Staffan before, and now me. I co-found a company called 55 Degrees. I'm just going to put that up there. My marketer will be happy. But I'm here today to talk to you about changing the way that we forecast, understanding the odds of any kind of forecast you give, by understanding, how likely it is that this thing will happen or that thing will happen or the other thing will happen. First, I want to ask you, how many people feel like their stakeholders expect certainty when it comes to the question, when will it be done? Definitely see some hands, right? Now, do you think certainty is realistic in the situations that you work in? I see some no shaking heads, right? Good, then you agree with Benjamin Franklin here, who says that, there's not much in life that's certain except death and taxes. And as an expat American, I can tell you that's true because I have to pay taxes no matter where I live in the world. That's just one of the benefits, I guess, of worldwide taxation. But we live in and we work in situations that just have a lot of complexity going on. And when we are being asked to give a forecast, we like to forget that the certainty isn't really appropriate for the types of things that we're working on. And we end up trying to give people forecasts that give, maybe just by lack of information, a sense of certainty that what I'm telling you is going to happen. So this is an example of a type of forecast we give. This is a Gantt chart, and there's nothing wrong with Gantt charts per se, but something that you need to understand about it is that it's one story of what could happen, right? Each line on this Gantt chart tells us sort of a start and an end date for an individual work item or group of work or something like that, an identifiable unit, okay? But we don't have anything on this Gantt chart usually that tells people how comfortable we are, how certain we are with the fact that we'll start and end this thing at that point. And when we don't give people that information, their mind is just going to fill in the gaps with what works for them. So if I give this to someone and I don't say, I'm not very certain about this, or I'm really confident about this, then they're just going to assume, okay, great, 100% awesome. I will go make all the unchangeable plans that I need to because I can count on this. Unless they've been burned a couple of times, right? It's sort of a little bit like a house of cards. I don't know if anyone else has ever had this, but when you make these complex plans and roadmaps, and this thing is dependent on that thing and the other thing, when one thing falls down, it's like the whole house of cards collapses, right? So it's really important to give people a better understanding of what you really mean and what you really think when you give them a forecast. And that's what we're going to talk about today, understanding the odds, because forecasts are like little bets. Each bet has a certain likelihood of whether it will, turn out in your favor or not. I'm going to sometimes refer to as when you meet your forecast, you sort of fell on the upside of that bet, sort of like a poker term, right? But when I have a situation that is outside of what I forecasted, say I took a little longer, that's like the downside of my bet. I fell on the other side of my odds. So we're going to talk about all of that today. But first, I want to go a little bit back to the certainty kind of question. So let's go back and think about how many of you in the room sit down and do lots of work breakdowns, sitting down trying to figure out how many hours it's going to take to do something, and then filling out complex project plans and things like that? Are we still doing any of that in this room? Or are people asking you to contribute to those kinds of things? I see one brave hand. Takes a lot of time, doesn't it? Right? Is it often right? No. Okay. That's because there is this concept of the 3 gaps. So one of the favorite books I've ever read is The Art of Action by Stephen Bungay. And this is really useful to have in your repertoire, this part of it, this conversation, when you're faced with people who are trying to help you buy in or make you buy into the fact that if we just plan a little harder, we can make a good plan that then we can trust, right? So let's say that someone's coming up to you and trying to get you to be certain by pushing you to just make a better and better plan. Well, you can say, okay, that's great. You know, we have these outcomes we want. We can come up with actions we think we need to do to get to those outcomes. And then those actions will then have effects, and hopefully those effects will give us our outcomes. So this sort of virtuous circle, right? Well, let's see what can happen to us along the way of going through this nice and tidy virtuous circle. The first gap we can fall into is the knowledge gap. So this is the space between what we know and what we can actually know at this point, and what we need to know to make the perfect plan. So how many of you feel you really believe in the concept of emerging information and Agile and getting fast feedback, because we can't know everything up front to make a good plan? Is that sort of, you agree with that? Okay. So then you already understand that there's this knowledge gap. There's stuff you don't know that you can't maybe even know right now if you tried, that you'll need to know to make that unbreakable plan. Okay? But let's say that I could wave a magic wand and I could skip, build a nice bridge over this knowledge gap, and I could know everything that I would ever need to know to make a perfect plan. Well, then I might get hit by the second gap, which is called the alignment gap. And this is the difference in between what we want people to do and what they actually do, right? Because you can give the same set of specifications or requirements to multiple people, and they might be interpreted in different ways, and different things can happen. And unless you are, trying to spec harder or be right there with everyone moving their hand to get them to do stuff, we all have our own, processing units inside of our head. We have our own brains, right? And we interpret things in different ways. And, there can be multiple ways to skin a cat, as they say. So some people might do something one way, and some people might do something the other way. So we can never really know enough about every single person that might need to take an action to program them right, or to make our specs right, or foolproof enough to ensure that it's very, very consistent, that everyone will do exactly what you want every single time, even if you make a perfect plan. But again, let's say I can wave that magic wand. Maybe I've got a genie, I've got 3 wishes, right? So my second one would be, let's get rid of this alignment gap. I'm done with that. That's not good. Then we can fall into still the third and final gap, which is the effects gap. So you have experienced the effects gap if you've ever done the same thing multiple times and had any variation in your outcome, right? That just means that there's a difference between what we expect to happen by taking an action and what might actually happen. Because we don't live in a closed system. Like, there's lots of things going on around us, and we can't control all those factors. So even if I execute my plan perfectly, sometimes results happen that I don't expect. So I can make a perfect plan. I can try to tell people exactly how to execute my plan, but I can't always control what will happen because of that perfect execution. So if we think of all of that, we have to just accept the fact that in many cases, especially the cases that we work in, there just is no planning hard enough to make a foolproof plan. A plan good enough that we can be exactly certain when we're going to deliver something, okay? So now, when you tell people that, you talk to them about these 3 gaps and everything, you know, their initial response is just, well, let's plan it harder, right? So here's the workplace version of planning it harder. It's going from Gantt chart to sort of this super massive work breakdown structure. We're going to spend about 4 or 5 times as long getting a plan that's, you know, maybe not even as predictable as the first one. Okay. So essentially what we've been doing so far, when we give people a forecast that we're really not sure about the likelihood of it happening, we're delivering something called a deterministic forecast. Okay? It basically says, yeah, this thing will be done either on this date or usually before this date, right? So there's a little flexibility there. This kind of forecast that we're doing is only appropriate, is the best word, when you can be certain. So we spend a lot of time just agreeing that we can't be certain, but yet we're giving forecasts. We've been taught how to give forecasts that are only appropriate for certainty. So now we have to think about, well, what do we do next, right? Because if more than one possible outcome can happen, we have to start thinking about the likelihoods of those different possible outcomes and which ones we want to bet on, right? So we need to move away from the type of forecast that doesn't give any idea of the likelihood or probability of the outcome I'm telling you. So if I tell you, hey, this is going to be done by the end of this month, you know, I could be 5% confident in that, but you think I mean 100. We're speaking different languages here. So a better way to work in this sort of uncertain environment is moving towards something called a probabilistic forecast. Now, what's cool about probabilistic forecasts, if I can geek out about data and stuff, and by the way, you do not have to be any kind of data whiz, a BI person, even a math geek to do any of this stuff that I'm talking about today. I'm the least mathy person in the world, and I can understand all of the math that you need to know to do this kind of forecasting for people. So a probabilistic forecast has 2 key components. So if you ever see these, you know you're looking at a probabilistic forecast. The first is that it has a range of outcomes. So if I say it'll be done on or before this date, I'm saying that it will, one of the range of outcomes of finishing sometime between today and 3 weeks from today, there's a lot of possibilities in there, right? There's today, tomorrow, etc. And then I'm telling you that I'm 85% confident that the real thing that happens will fall into that range. So what I sort of mean by that is that there's an 85% chance that it'll be done between now and 3 weeks from now, or by X date. And because I can look at all the different outcomes, and if I look at my data, I can even see, how likely it is to happen earlier or later, then I can give people an understanding of, I can give people an understanding of all the different possibilities there are. And that means it's more appropriate to talk this way when there is uncertainty present. So this is what we're trying to do here, is move towards a more probabilistic way of talking. Now, we see probabilistic forecasts everywhere. The weather forecast is a probabilistic forecast, right? So we're trained to think about this way. We just don't think about this in our work. If you see the weather forecast and it says, there's an 85% chance of rain between noon and 1 p.m., right? That's a probabilistic forecast. It's got the probability, the 85%, and it's got the range, noon and 1. It gives you a really good idea of what's going to happen. I also know that there's a 15% chance that it won't rain, between 12 and 1, right? So it gives us a lot of risk information. I get to see a couple kinds of risk. One is, how wide is that range? To be 85% confident, you know, do I have to have a really wide range of outcomes, right? We'll talk about that more when I get to the data. And then the probability itself, when I tell you 70% or 85%, I'm not saying it, but you infer sort of that gap, that downside. The 85% means there's a 15% chance of something happening that's outside of that range that I'm telling you. So we're going to take this kind of concept and talk about how you can take just a little bit of data about the work that comes out of your process, the data that you might generate in Jira and Azure, or maybe even on sticky notes on a physical board. You can do all of this data even with a manual process. You don't need a specific tool. You don't need a person with a master's degree in statistics. You just need a pencil, a sticky note, and maybe sometimes an Excel file. Okay, so we're going to talk about single item forecasts. So when you want to know, hey, this one thing that I need you to do, this individual piece of work, when could it be done, right? How long will it take? And then we're going to talk about how to take the same data and look at how long it's going to take to do a set of work. And with multi-item forecasts, we all sort of know that there's two different ways to look at this data, or to look at the requests you get, rather. Sometimes you'll get someone saying, okay, there's a date that we have to hit. I can't move that date. You know, when I worked at Turner Broadcasting Systems back in Atlanta ages ago. And the website that I managed, it was a group of developers that worked on NBA.com, the National Basketball Association, so the professional basketball league, right? So we had a bunch of tentpole events throughout the year. We had draft, we had the playoffs, you know. I'm sorry, but I don't have enough pull to change that date so that we can move it to when we'll be ready for the website to be done, right? So sometimes you have a fixed date, and you have to know how much work you can get done by that fixed date. And then you have sort of fixed scope. Like, it doesn't matter, you know, when it will be done is less important than all of these things have to be done for us to get value. So when can we do all of these things? So these are the 2 to 3 types of forecasts that you can do very easily just using a little bit of data from your system. All you really need out of your system are just 3 tiny pieces of data. Now, you can do more with more, but to do those 3 types of forecasts, 3, not 4, you can do that with just this. So I have, you know, some idea of something that represents the item. If you were here in the last talk with Stefan, he talked about, you know, reductionist versus sort of value-driven. So don't be thrown off by the fact that we're talking about data or that we've got, you know, sort of irrelevant named things. It's just sort of any ID that you want to have, whether it's alphanumerical, whether it's more human readable, that's fine. We need a date that each thing started, and we need a date when each thing finished. And if you have those 3 data points, you can do this work. So that's what I meant by when, if you say you don't have Jira, you don't have Azure, or you don't have my tool or anyone else's tool, if you got stickies on a whiteboard, when you move that into, when you start the work, whether maybe you're not even using a Kanban board, right? When you start that sticky note, write the start date on it. When you finish that sticky note, write the finish date on it, and now you've got the data that you need. It's not complex. Okay. To do single item forecasts, there's a flow metric that we're going to use called cycle time. Okay? And this answers how long will it take. Now, cycle time, you might hear other words for this metric. You might hear lead time, you'll hear cycle time too. You might hear flow time, you might hear other names. For me, the name is sort of irrelevant as long as you're talking about the total elapsed time it takes from a work item to go from when it started to when it finished. Okay? Now, there's a couple things in there that are important. There's the concept of start and finish, right? So that's something that you would think is obvious, but isn't. You could get 6 people in a room, and they might have different views on what start means and what finish means. So what's cool about what I'm going to tell you today and how you can do these forecasts, it can sort of zoom in and zoom out from any start date to any finish date. So when you sit down to make your forecast, the first thing you want to talk to each other about and get on the same page about is what you mean by start and what you mean by finish, so that when you tell someone, here's how long it will take, they know you mean from here to here, and they don't have a different picture of what we're talking about. Okay, the other thing is total elapsed time. You can play around with, trying to get working hours and stuff like that. Not even going to dive into that, but I'm a really big advocate for just talking in calendar time because it really makes everything less complex. If you think about it, if you ask me, when's this thing going to be done? And I say, let's say it's December the 1st. And I say 30 days from now. Chris, when do you think that thing is going to be in your hands? If it's December 1st and it's 30 days, 31st of December, right? I mean, because you can do math and that's what you think. Chris isn't sitting here thinking about, well, there's weekends, and maybe in December you're thinking about holidays. But if I've got a global workforce, no one is thinking about this person celebrates, this type of holiday. The holidays in India are different. That's too much load to put on people. Everyone speaks calendar, right? So if we talk in the terms that everyone understands, we'll have less confusion, and it's a lot easier. So cycle time, total elapsed time between a start point and a finish point. Nothing more complex than that. Now, how we calculate that is I'm going to use date, but I just wanted to call out that even though I'm using day as my unit, you can use minutes or hour. You can use any granularity you want. But if I'm calculating cycle time in days and I want to talk forecast in days or something like that, then I'm going to take the finish date minus the start date and add 1. We add the 1 to make it inclusive of both days, and we don't end up with any 0-day cycle times, etc. Okay? So nothing too complex there. Now, how we visualize that data is on a cycle time scatter plot. So it's sort of what it says on the tin. It's a scattering of dots plotted on this chart. So on the bottom axis here, we've got the date series of when it was completed. So earlier things over here, later things over here. So I can see just from that a lot of patterns of, hey, there might be more dots here versus there on the horizontal axis. Now the vertical axis is that cycle time. So that number of days it took to go from start to finish. So I can see, whoops, sorry about that. I can see maybe this item right here that it finished, about April the 10th maybe, and it took 12 days, right? I can see that very quickly from looking at the chart. So if I plot each one of my items and look at that, I sort of see the voice of my process or system. In other words, I'm seeing what you've been able to accomplish so far based on all the conditions that you've faced, right? I may not know from looking at your data how your team is structured, what pressures you have on your system, how many things you do at one time. All of that impacts where these dots get plotted. There's a lot of things that will contribute to cycle times being long or short. Stefan in the talk just before us talked about multitasking. That's one input. The complexity of work is another input to how long it takes, but not one of those drives it itself. Together, all those conditions drive how long it takes for you to get work done. But what I can tell is that if the conditions that you continue to have are similar to what you had when you generated this data, then I should be able to look at this and use it as a pretty good indication of what's likely to happen going forward. Okay? Sort of call that the underlying rule of thumb, and we'll touch on that again. But you notice we have some percentile lines here, and you're probably thinking probabilities. These are going to come together here. When we're looking at how to forecast how long it will take to do a single item, it's actually not super complex, because the way you figure out what's likely to happen when you don't know the answer is to do the thing over and over and over again and find out, like a scientist, right? So if I don't know what the likelihood is of rolling snake eyes with dice, I can roll 2 die over and over and over again and calculate the likelihoods, right? Well, good news, we have a whole bunch of examples of us finishing a single work item over and over and over again, right? So now I can look at all those outcomes and get an idea of what's likely to happen. How do we draw these percentile lines? How do we get these probabilities? Because if I look at this, what this is telling me is that 50% of the items that we've completed here were finished in 7 days or less, right? 85% of the items we finished in this data set were finished in 16 days or less. So you're starting to get an idea of how we could use this data to give people some forecasts, some probabilistic forecasts of how long it might take us to do a piece of work in the future, as long as nothing significantly changes in our situation. Now, how do we draw these percentile lines? There's actually not some complicated statistical formula here to figure that out. It's literally just, where's the point at which 85% of the dots are plotted on this chart? So let's say there's 100 dots here, and I want to draw that 85 percentile line. I'll count up from the bottom, 1, 2, 3, 4, until I find dot number 85, and I just draw a line, right? Because 85 dots out of 100 is 85%. So it works with any number. You just have to be able to know what 85% of X number is, right? And so then I have that. I can do that with any percentile that I want. And what I'm able to tell people is that, you know, just like I said, 50% of work took 7 days or less. If our situation doesn't change that should allow us to do anything different, I should be able to say 50% of the time we'll finish work item in 7 days or less. Now, maybe you're not super happy with that, right? So we have all these other percentiles that you could look at. That takes us to our next question of which probability. I use percentile, probability, likelihood. They're all sort of the same, so sorry if I mix the terms. But how do you know which one to use? Which one's appropriate for your needs, right? Let's think about it a little bit. If I give you a 50% likelihood, I'm wrong as much as I'm right? That doesn't feel good from a risk perspective, right? My stakeholders at work are probably, that's almost useless to tell them whether it's, 50% chance. So what we want to think about is, what is the consequence of being, quote unquote, wrong with our forecast, of falling into the downside? How serious is it? Like, do we just need to fix forward and keep going? So what? We did that bad. We'll learn and go from the next time? Sorry. Or is it sort of a life and death situation, right? Because if it's a life and death situation, I'm going to try to get as high of a probability as possible so that there's as little risk as possible there's the smallest downside I can possibly have. What's the first question, do you think, that people might ask when we're talking about which probability do we want to use for forecasting? Anybody have an idea of which number people want us to use if we're asking our stakeholders? Sorry? 100% is usually, can we just use 100%? What's the answer to that based on what we've already talked about today? No, we actually can't, because there's always something that could happen that's never happened before. So even if we counted for every single dot in our chart, really you could only be like 99% sure, which, it's like saying, hey, there was actually a Hurricane Julia that just happened. So it's like, okay, Hurricane Julia is coming and she's going to hit Earth, right? Not super helpful, because everyone on Earth is supposed to take cover, right? It's so wide, there are so many possibilities as to be sort of useless. Because from a forecasting perspective, what that means is I'm going to really pad my estimate, because I'm telling people things can take anywhere from 1 day to 50 days. And some people that might be 1 week to 2 years. I mean, that's also about as useless as our 50%. So we need to figure out the balance of how much risk are we okay with versus, how many of those longer and longer items do we need to include? Because the higher confidence we go, the wider our range of outcomes, right? Because if I need to be more confident, I need to include more of my outliers. Okay. Yeah, so finding the right balance. And just so you know that a lot of times when me or someone else talks about probabilistic forecasting, we'll use 85%, but I just want to take a moment and say that that's not a magic number. It's just because you hear it all the time doesn't mean that's the number you should use. It's just a sort of general that if you don't know, it might be a good one to start with because, you know, not too much of a downside. But think about your context and your situation of how much risk you want. Okay. And so when we do that, when we decide what we want our probability to be and we have our data, then we can use the right language to give the forecast because that's as important as anything else. I can't control what people hear, but I can control what I say. And I might have to say something over and over again in multiple ways to get them to really hear what I'm trying to tell them. But if I try really hard, I can give them as much information as possible. So 85% of the time, we're going to finish any work we start in 16 days or less, right? That might be good enough for people. You can also say, that means there's a 15% chance that it will take longer. You have to sort of know your audience, and you have to know what words you want to hear from them, or they need to hear from you to really understand. But it's going to take a long time, even when you say those words, to retrain people that you can't have that 100%. Because they'll hear 16 days or less, and sometimes they'll just tune out the rest. So sometimes you really need to repeat things over and over and explain sort of what you mean by that and how you came to it to get them to really understand. We already covered that underlying rule of thumb. If you have more questions about it, that situation where, you know, the data that we have represents a certain set of conditions. It was generated by, you know, the number of people on your team, the type of skills they have, you know, that kind of thing. If you have a significant shift in your situation, then you'll have to take your data with a grain of salt from a forecasting perspective. And that also brings me to the fact that I don't say it enough in this talk. We want to continuously be checking our forecasts. So it's important, even when we're doing the single item forecast, and you know, you don't always have to keep going back to that person and re-updating them like you might on a project level forecast. We still want to keep track of whether or not we're staying predictable. So today at 16 days or less for our 85%, are we keeping that level of predictability? Is it getting better? Is it getting worse? So keeping an eye on this is really important. Okay, so now the second part, the multiple item forecasts. This uses a different metric called throughput. Okay, we're asking the question for multi-item forecast, when will all of these work items be done? Okay. Now, throughput is a rate metric. It means it's the number of things in a given unit of time. It's similar to velocity, but it represents an actual count of items that are finished. So I suggest that we don't proxy with something because we have the metric of exactly what we're trying to forecast. We're trying to forecast how many items can we finish. So let's use a metric that shows how many items we finished instead of trying to convert some other metric that may or may not represent that. So throughput is the total count of items that cross your finish line in a given period of time. So this many a day, this many a week, this many a sprint, et cetera. You can determine what time unit you want. As long as you're consistent in both the data you're collecting and the forecast you give, then that's good. I'm going to use days in my example. Okay? And even though I've got start here, it really doesn't care about when they started. Throughput's only looking at how many crossed that finish line. So it won't know if you're doing sprints, it won't really care about how many sprints it took you to finish. It's just the rate at which you finish work. Even if that other information is important, it's not part of the answer to this question. Okay, so we have a very simple kind of chart called a throughput run chart. And this one shows me the number of items we finish each day. So again, the time is on the bottom, and the vertical axis is the number of items that cross that finish line. So let's see, we have anywhere from like 12 items in a day, that must have been a really awesome day, to zeros, right? And I'm counting all my days, thank you. And so I've got, some double zeros, which often means weekends. It's really important to know your 0 days, as well as your, the days you deliver, especially when I want to talk to people in calendar time. So I want to include my weekends. I want to include all these times so I can talk in terms of calendar. If I exclude my 0 days, then I'm going to give people a shorter forecast than it really will take. Okay. Now, I could look at this, and I could do something similar to the cycle time, where I could say, on any given day, here's the likelihood of us finishing this number. But generally, when I'm trying to forecast a collection of items, it's going to take more than 1 day. And I don't want to get into the trap of adding up that and doing averages of days. There's a better tool for that called a Monte Carlo simulation. And you can do one of these by hand, because I promise that you don't need tools to do this. You can. Super tedious. So there are Excel spreadsheets that you can get for free. There are tools that help you do this, that integrate with your systems. So regardless of your needs or budget, you can find a way to help you use this kind of tool without a lot of cost or confusion. Okay, so this is just a screen grab from a tool. Yours might look a little different, but I'll explain what we're looking at here. So the chart, that's our throughput run chart, because that's the underlying data the simulation's going to use. Now, in any simulation, the important thing is the sort of parameters that you give it. So if I'm looking at a fixed scope, I have a number of items that I need to finish. I need to tell my simulation 2 things, besides the rate at which we finish work, which is sort of baked in. I need to tell it when we're planning on starting, right? And then I need to tell it how many items are in my scope as of right now. So maybe right now I know that there's 45 things that have to be done. That could change. You come back and reforecast that. But as of right now, here's what I know. And then what's going to happen is that a Monte Carlo simulation will run thousands and thousands of trials of you doing 45 items over and over again based on how fast you finished work in the past to understand that whole range of outcomes. So how does it do that, right? Okay, so let's say I have a fixed scope. I need to finish 45 items. I'm going to do 10,000 trials on this Monte Carlo simulation. So trial 1, day 1. It goes and it randomly grabs, it's like mixing all up those dots and grabbing one out of the pot. Oh, and saying, oh, 12, great, we're on the way. And so day 2, it pulls randomly another value from your historical data. Oh, today's 0, that's a bummer. And it keeps grabbing numbers until you hit 45, and then it sees how long did it take. And it'll do that 9,999 more times. And then what you don't see here is that there's these back-end charts and basically histograms of seeing how long every trial took and how often you hit that value. A better way to look at that, especially if you're talking to stakeholders, is to look at it on a calendar. Because then I can go say, oh, there's an 85% chance that we'll finish these 45 items on or before May the 25th. And now if they go, oh, crap, I really wanted it on the 19th. I really needed it then, right? Then you can say, well, based on everything we've done in the past, this is what we're able to do. What are we going to do differently to let us experience a different outcome or to improve the odds that we can finish that on the 19th? And hopefully that gets you a little more towards solutions and a little bit less about the frustration of the date. Now for fixed date, it's very, very similar. The only difference is the second thing that you pass in, because this time we wanted to tell us the number of things we can fix and we can do in a given time. So we needed to give it the start date and the end date. So it sort of fills in the third thing you don't give it, right? So now I want to know how many things can I do in this month, right? If you can use this for sprint planning. So if you have a 2-week sprint, you put 2 weeks in and you can think about, okay, I want to plan how many items we can do. I want to use maybe the 85% confidence. So 85% of the time, we finish 67 things in that time period. So, that's how many things we think we can do. That's a bit inflated for general purposes. We usually don't think 67 items ahead. Maybe that's more like release planning or something. But if it tells you, hey, 14 things, right? Then you go into sprint planning and you say, well, let's maybe pull in 12 to 14 things. Still gives us a margin of error. We're still likely to finish most of these things in our sprint. Same kinds of discussions about, I wanted more. Well, here's what we've been able to do so far. What are we going to do differently to change the outcome? This is a whole nother talk, but you can take a Monte Carlo simulation and do it cross efforts. So if you're interested in that, talk to me. But the key takeaways I'm really hoping that you get out of this talk is not that you leave feeling like an expert in using your data for forecasting like this, but I would love you to take away the thought that if more than one outcome is possible, let's move to something that recognizes the likelihood of the outcome you really want, right? That to do that, you have to be able to tell people the probability and the range that you are likely to fall in based on that. That picking the right probability is based on the risk that you're comfortable with, that you can afford, right? And if doing that means you have a super wide range, then the next thing you want to do is work on bringing that range in without reducing your confidence by working on, like, improving your work item age and your cycle times. Yeah, that's a marketing thing. So I just wanted to thank you for listening, and I'd love to hear if you have any questions that I could answer. Yeah, thanks. And I'll answer on Lietuva or pretty much anything but carrier pigeon. So Twitter, Facebook, whatever. Yes.
Yeah.
Question.
Thank you very much.
Yeah, thank you.
I usually use these tools as well, and I like them very much.
Nice.
So, but usually the objection I get from my customers is, okay, when we work with throughput, then we need to have the same sized items. So how do you respond usually?
Yeah, well, I say you really don't. And I say that trying to have the same size item, like make everything the same size, causes more problems than any value it brings. What we want to do instead is make things sort of right-sized. So there's two quick things. One is that the size of your items, just like the complexity of your items or your work in progress limits and all of that, are factors that go into how long it takes to do an item and how many items you do. So if you have lots of big items, then some things are going to take longer. If you have lots of small items, some things are going to be smaller. So when you look at your data set, it's expecting that you keep roughly the same mix of items. So if you have large items and small items, and you've got sort of a steady mix within reason, not exactly the same, just approximately the same, then you can use your data to forecast that. But if you all of a sudden shift from really small items to really big items, or you switch from 75% big to 25% big, that your data shape might change, right? So then you have to maybe use this as input and not as certain, and start generating data and then picking up using your data for the forecasting. So there's an American phrase, it works out in the wash. So if it's the same mix of stuff, and that stuff is just inclusive of so many things that contribute to the shape of your data. So hopefully that's helpful, even if it's also a little vague. It's just there's no one perfect answer for everything. But the right sizing thing is that something that we teach in using flow metrics and things in, say, a Scrum environment is when we go to cycle time and we're picking our percentile line, say we want to give the 85th percentile. So we want to tell people, we want to set an expectation, maybe even just internally to ourselves, so sort of a service level expectation, that we should take 16 days or less to finish most things. So when we start looking at sizing items, one of the gut checks should be, does it feel like it's going to fit under that most of the time? And then just those little checks help us not just be super uncontrolled. And a lot of times, Scrum teams will start looking at their data, and they have 2-week sprints, but 85% of items take 35 days or less, and they see, oh, there's a really big disconnect here. And ideally, we get to the point where maybe that 85th percentile is not longer than maybe half your sprint, so that you can start things and still likely finish them, you could within your sprint, but you can start something halfway through your sprint and still have a high likelihood of finishing it, so you don't have to start everything on day one. Yeah.
Thank you. And now more questions.
This is an actually question about the accuracy of the data.
Yeah.
So, for example, there's some ways an anti-pattern where the team just updates the board just before the stand-up or just before a weekly meeting.
Yeah.
Any tips how to ensure the accuracy of the data?
Mm-hmm. Yeah, I mean, you're not wrong. You're really right. Garbage in, garbage out. If we're using your data to help you do things like understand, what you expect, so we can use this data for forecasting and for becoming more predictable, it does require some level of accuracy. Now, it doesn't need to be perfect, right? I don't need you to go do something to the card every time you go take a coffee break so that I know you're not working on it yet or stuff like that. But what I would say is that exactly, you do need to have it sort of be accurate. How do I get people to care about that? I get them to understand why it matters and how just making a little tweak to doing that. Instead of thinking of that as something you go do later, think about it as giving the most up-to-date information to people on what's going on, so I don't have to bother you as much, so that I don't have to ask you to estimate as much. And all of these things that can be benefits from just taking a little time, even once a day, to update the tickets instead of maybe once a week. So I don't need even hourly if I'm looking at a daily time frame. So good question. That's really good.
Thank you. Do we have more? If no, okay, the first thing.
Thanks, Julia. Perfect presentation.
Thank you.
My question is about high-level estimates. Well, usually you can come up with a situation that you have not the tasks or chunk of works in the backlog, but you have like a projects.
Yeah.
And the shareholders, they would like to know, will it fit into a year, like time for this team? And if it doesn't, maybe we need to hire more people or scale the team or something. Will the same rules apply for the bigger chunk of work if you have the historical data, like we can deliver 3 projects in the year, so maybe next year we will do the same 3, or it should be done in some some other manner?
No, that's a great question too. There's a couple ways of going about it. So when you're looking at how long it takes to do a single piece of work, that doesn't necessarily have to be a story level item. If you know the cycle times of your epics or your projects, you can do that. Now that's a bit less accurate than maybe looking at the project and seeing how many things are inside of it, because we get a little more granularity that way. So what I know some people do, and what we're working on doing in one of our tools, so we're still sort of figuring out how we want to do this, is looking at the projects or epics or whatever your word is that you've done in the past. What's the range of how many things that broke down into? And so we might be able to say 85%. Someone even hijacked the cycle time scatter plot, and instead of cycle time, made it show how many things ended up being in this piece of work, this larger project, so that I could then say, when I want to do my fixed scope or something, I could understand how many items I'm likely to have. So for early planning, instead of actual forecasting the work as you know it right now, you can use that estimate of, I'm looked at my past data, here's how much work ended up being in epics like this or projects like this as a general rule, and I'm getting that high level forecast. But then you always have to come back. I'm just going to keep saying continuous forecasting. It's like your GPS, you don't turn it off when it tells you, okay, 14 minutes, shut it down, right? 14 minutes, and then I leave it on, so when I hit traffic or I get a patch where I can just fly through, I'm getting that updated forecast the whole way through. And as we work through the work after that high-level forecast, when we're actually doing it, we need to not get surprises, and we do that by continuously reforecasting as we finish work, as new work gets added in, so that we don't make people angry by nasty surprise at the end. So yeah, hopefully that helped a little bit.
Yeah. Thanks for your answer.
Thanks.
Thank you. And right now,
It's
I
fine.
would like to say a huge thanks for you for coming here,
Thank
for
you.
the audience who listen to us.
Thank you.
And we have some presents for you from Lietuva,
that's so
Agile
nice.
Lietuva,
Thank you.
and also our partners, Present Connection.
Oh, and feedback. Thank you.
Yeah, and 3 things more. One is Menti overwear for Julia, Menti for overall
Should give you the
conference to read, and we are waiting for you in the hall of 5.1, so the main goal, the main hall. See you. Thanks.